$1,200. That's what one homeowner spent on a highly rated, best-selling 2,000-watt solar generator. He did his homework, read the reviews, and stored it fully charged in the garage, ready for exactly one moment: a bad storm. That storm came last October. Grid went down at 11 p.m. Basement started taking water. He rolled out the generator, connected his standard half-horsepower sump pump and his French door refrigerator. Display read 100% charge, 2,000-watt capacity. The math seemed perfect. Sump pump at 900 watts, fridge at 200 watts, leaving him 900 watts of headroom. He was fine. The float switch engaged. The refrigerator compressor cycled on. For about half a second, the generator tried. Then the alarm screamed. Overload. Screen went dead, AC output gone. The basement flooded. Tens of thousands in damage, hundreds in spoiled food. That unit was not defective. It performed exactly as its engineering permitted, which was nowhere near what its marketing promised. Today, I'm exposing 7 engineering realities the portable power industry is counting on you to never figure out. The last one isn't about a spec. It's about a deliberate business model that guarantees you spend thousands more. Don't skip it. Find secure links of our recommended products in the description below. Let's get started. Point 1. The 2,000-watt rating lie. Here's the number the box never shows you. It's called locked rotor amps, the massive surge of raw electrical current required to break a motor's static friction and force it from a dead stop into full rotation. Every essential household appliance you own – sump pump, refrigerator compressor, freezer, HVAC blower – runs on an AC induction motor. When that motor is sitting still, it's essentially a short circuit. The moment power hits it, it draws maximum amperage, 3 to 6 times its normal running load, for the first 2 to 3 seconds, until counter EMF kicks in and drops the current back to normal. Here's the math from that flooded basement. A half-horsepower sump pump runs at roughly 900 watts, but its locked rotor surge demands 2,400 to 3,000 watts of instant power. A French door refrigerator runs at about 200 watts, but its compressor startup spikes to 1,200 to 2,000 watts. If both cycle on simultaneously, the combined surge hits 4,000 to 5,000 watts, straight into a 2,000-watt inverter. The cheap internal components can't absorb that thermal spike for even a millisecond. The overload protection trips. Game over. The industry knows this. By advertising continuous watts and burying surge requirements in fine print nobody reads, they transfer the liability of failure entirely to you. Point 2. The battery chemistry fire sale. Right now, the market is flooded with $899 to $999 solar generators, running flash sales and clearance events. Here's what's actually happening. Manufacturers are racing to dump obsolete NMC battery inventory before buyers figure out what LiFePO4 cells are. NMC, lithium nickel manganese cobalt oxide, is the old chemistry. Its layered structure physically fractures a little bit every charge cycle. Over time, the cathode micro-cracks and the battery permanently loses its ability to hold a charge. NMC batteries are rated for 500 to 1,000 full cycles before dropping to 80% capacity. Under real heat and heavy use, most clearance units don't survive past 800 cycles. LiFePO4 (LFP) uses an olivine crystal structure with phosphate oxygen bonds that act like molecular scaffolding. It resists degradation cycle after cycle, delivering 3,000 to 6,000 plus deep discharges before hitting that same 80% threshold. The cost per cycle math is brutal. A $999 NMC unit rated for 800 cycles costs you $1.24 every time you cycle the battery. A modern LFP unit at a similar price rated for 6,000 cycles costs 15 cents per cycle. That clearance deal isn't saving you money, it's transferring the steep depreciation of an obsolete chemically volatile asset directly onto your balance sheet. Point 3. The usable capacity illusion. That 2,000 watt-hour number on the box is a gross theoretical figure. Here's what's hidden inside it. First, the battery management system. The internal computer governing charge and discharge locks away 5 to 10% of gross capacity at both ends of the voltage curve. Fully depleting a lithium cell causes permanent internal damage, so the BMS prevents you from ever actually reaching zero. Second, your appliances need 120-volt AC power. Your battery stores DC at 48 to 51 volts. The inverter switches that current back and forth tens of thousands of times per second to simulate a clean sine wave. That process generates heat. That heat is lost energy. Most portable inverters operate at 85 to 90% efficiency under real loads. Run the actual math. 2,000 watt-hours times 0.90 for the BMS buffer times 0.85 for inverter efficiency gives you 1,530 watt-hours of true usable output. You're getting 1,530, not 2,000. That's a 23% shortfall. If you're running a CPAP machine or keeping food cold through a 4-day storm, that gap is not a footnote. It's the difference between making it through and not. Point 4. The phantom drain trap. This one blindsides people every time. You charge your generator to 100% before a storm. You switch the AC inverter on so it's ready in the dark. No appliances plugged in, just waiting. Within 24 to 48 hours, that battery is dead. When the AC inverter is switched on, the internal circuitry fully energizes whether anything is plugged in or not. The microprocessors stay active. The transformer stays fully magnetized. The switching components keep running at high frequency just to maintain a stable 120-volt sine wave, ready for an instantaneous load. That standby state draws a constant baseline from the battery. Real-world testing shows approximately 66.7 watts per hour of idle consumption on heavy-duty inverter systems. Here's the math. 1,530 usable watt-hours divided by 66.7 watts of idle draw equals roughly 23 hours to complete self-depletion. No appliances, no storm yet. Just the inverter running itself into the ground. During the emergency, the consumer grabs the generator, plugs in a critical device, and stares at a 0% display. Budget units have no smart auto shutoff or idle drain. It just keeps drawing. Point 5. The solar-ready input bottleneck. The phrase solar generator implies seamlessly recharging from the sun. Budget units have engineered that capability into near uselessness. Every solar generator uses an MPPT controller, maximum power point tracking, the hardware bridge between your panels and the battery. It has hard limits on input voltage and current. Budget 2,000-watt units have two specific traps built in. Trap 1 is the voltage minimum. Some older 2,000-watt models require a minimum open circuit voltage of 35 watts before the controller wakes up and accepts a charge. A standard 100-watt portable solar panel produces roughly 21 to 23 watts. Plug that in and the generator rejects the power entirely. 0 watts. Consumers are forced to wire panels in series just to cross that threshold. And in a series configuration, one shadow on one panel drops the entire array's output by up to 90%. Trap 2 is amperage clipping. Budget controllers cap incoming current at 10 to 12 amps to save money on internal components. Modern panels routinely push 13 to 15 amps at peak sun. The controller takes its 10 amps and discards the rest as heat. You lose 20 to 30% of your raw solar harvest before it ever reaches the battery. In an emergency with 5 usable hours of winter sunlight per day, that restriction turns a 2-hour recharge into a multi-day deficit. Point 6. Following the money. None of this is accidental. When you buy an all-in-one 2,000-watt unit, you're buying 3 components permanently sealed into one chassis: a battery, an inverter, and an MPPT controller. The NMC battery degrades past usefulness in 3 to 5 years. At that point, the inverter and controller are typically still working fine. But the chassis was intentionally designed without external battery expansion ports or modular communication protocols. You cannot swap the dead cells. The entire $1,000 unit goes in the recycling bin. The manufacturer forces you back into the store. Every feature they deliberately omitted – expansion ports, modular battery slots, open protocols – is a lever that guarantees a future full system repurchase. They're not selling you a generator, they're selling you a subscription to a $1,000 replacement cycle every 4 years, backed by the quiet certainty that the NMC chemistry will expire right on schedule. Point 7. The smart buyer's math and the 2026 fix. Forget continuous watts, here is the only math that matters: cost per cycle projected over 10 years. A generic 2,000-watt NMC clearance unit at $999, rated for 800 cycles, costs $1.24 per cycle. The EcoFlow Delta 3 Plus at $649 uses LifePo 4 cells rated for 4,000 plus cycles. That's 16 cents per cycle. The Bluetti Elite 200 V2 at around $899 uses LFP cells rated for 6,000 plus cycles. That's 15 cents per cycle. The cheap unit is the most expensive unit on this list. Now, here's how these units actually solve the engineering traps we just exposed. The Bluetti Elite 200 V2 ships with a 2600-watt continuous inverter, not 2000. Its surge capability reaches 3600 to 3900 watts via powerlifting technology, which is specifically engineered to absorb the 2400 to 3000 watt locked rotor amp spike of any heavy sump pump without tripping. The MPPT controller accepts up to 1000 watts of solar input across a 12 to 60 volt window at up to 20 amps, eliminating both the voltage minimum trap and the current clipping trap. Real-world solar recharge in roughly 2.4 hours. The EcoFlow Delta 3 Plus attacks the ecosystem trap directly. At $649 with a 1024 watt-hour base, it features X-Boost technology that intelligently manages voltage delivery to sustain appliances up to 2400 watts, with an 1800-watt AC output that handles refrigerators and power tools without fail. More importantly, expansion ports allow external LFP batteries to scale the system from 1 kilowatt-hour up to 5. When your needs grow, you buy cells, not a new inverter and charge controller. For whole home backup involving 240-volt loads like deep well water pumps or central HVAC, the EcoFlow Delta Pro Ultra operates in a different category entirely. It delivers 7,200 watts continuous at 120 or 240 volts split phase, scales to 90 kilowatt-hours of total LFP storage, and functions as a 0-millisecond uninterruptible power supply, transferring loads during a blackout without resetting sensitive electronics. At $4,099 for the base unit, it covers everything a standard unit physically cannot interface with. Here's what all of this comes down to. The $999 clearance sale is a $1.24 per cycle NMC battery degrading towards its 800-cycle grave, paired with an inverter that can't start your sump pump, an MPPT controller that clips your solar panels, and no expansion capability. So the whole thing becomes e-waste in 4 years on schedule. Smart buyers evaluate locked rotor amp surge capability, LFP cycle life, MPPT voltage window and amperage ceiling, modular expandability, cost per cycle across a 10-year horizon. Run that math, and the Delta 3 Plus, the Elite 200 V2, and the Delta Pro Ultra are not the expensive options. They are mathematically the cheaper ones. Don't wait for the overload alarm to tell you what you should have known before you bought. If this saved you $1,000, hit like and subscribe to Valid Consumer. Share it with someone shopping clearance deals right now. Tell me in the comments, what appliance do you absolutely need your backup power to start without fail? That answer tells you exactly what surge rating you actually need. Recommended product links below. See you in the next one.